Hi everybody, we are starting a brand new topic today and it's going to be all about non-factorable quadratics, but this word quadratics is going to keep coming up and up and up again. So as you can see here, we're looking at a really different form of a quadratic equation. Ax squared equals c. So in this first few questions, they want you to name a value of x or values of x that would make each of the following equations true. So just look down the line and can you tell me what value for x, when you square it, would equal 4? Okay, most people will immediately say, oh, x can equal 2 because 2 squared equals 4. And that is true, right? And the next one they would say, when x equals 1, because 1 squared equals 1. But I want you to think really hard. Is there another value that I can plug in for x, and it would be still, when you square that value, equal to 4? Hopefully, some of you are saying, if x is negative 2. If you square negative 2, you also get 4. So not only could x equal positive 2, it could also equal negative 2. Well, same thing here. If I took negative 1 and I squared it, what does that mean? It means negative 1 times negative 1, I would get positive 1. So not only is positive 1, but negative 1 is also a value for x that could make that statement true. So let's think about where I'm going with this. Take a look at the next one. X squared equals 9. What two values could x be? Hopefully you're all saying both positive and negative 3, and that's another way for you guys to write it. You could show it like that. You could show it x equals negative 3 and positive 3, but there are two values that would make that value true. You could even show it like this, negative 3 and positive 3 in solution sets. So what values could x be if x squared equals 25? X could equal 5. X could also equal negative 5, because if I square 5, 5 squared means 5 times 5, I get 25. Negative 5 squared equals negative 5 times negative 5, which gives you positive 25. So in this last one, hopefully you'll all know, not 50, both positive and negative 10, right? If I have 10 and negative 10, so notice, how many answers did you have in all of those questions? 2. You should have 2 solutions. And the reason you should have 2 solutions is because they're all quadratic equations. The way you know you're looking at a quadratic equation is because it has a degree of 2, or the highest exponent is 2. And normally you guys see it in this form, ax squared plus bx plus c equals 0. Well, that's a basic trinomial. But technically, if you have the highest exponent of 2, you know you're looking at a quadratic equation, okay? So your a, your b, and your c, okay, are all numerical coefficients, and x is an unknown variable. The only rule is that a can't equal 0. Well, a can't equal 0 because if you plugged a 0 in for a, then the x squared would drop out and it would no longer be quadratic. So again, let me just make myself clear that a quadratic equation, okay, means your highest exponent is 2, okay? So I want you to go through and circle what you think is quadratic. Well, that would mean it's going to result in your highest exponent being 2. So when you look at the first one, 2x plus 6 equals 4, this is linear. No good. But the next one, x squared equals 4x, it's quadratic. Highest exponent is 2. In this next example, nope, this is linear. Why is it linear? Because your highest degree is 1. X to the first power makes it linear. 4x squared, done. You don't even have to go any further. Highest exponent is 2. It's quadratic. Okay, this next one is no good. What's the highest exponent? It's 3. That is what we call a cubic function. But look at your next one. It's quadratic. Your highest exponent is 2. Nope. In this one, linear. Highest exponent is 1. Okay. This next example, you'll say, oh, it's linear. Highest exponent is 1. But if you multiplied through, you would get x squared plus x equals 4, which makes that quadratic. Highest exponent is 2. This one, no good. Kids will say, oh, but if I add those together, but if you added those together, you would get 3x plus 6 equals 5. It's still linear. Now look at this one. This is a proportion, which means you cross multiply. If you cross multiply, you would get x squared equals 36, making that quadratic. This next one, no way, no exponent of 2. It's linear. Same thing here, linear. Nothing with an exponent of 2, okay? So hopefully you are able to see something is quadratic because the highest exponent is 2. So another way we could classify those beginning few equations is we call them incomplete quadratics. And the reason they're incomplete is because there's no bx term. So think about it. When you have your ax squared plus bx plus c equals 0, technically we could rewrite that by, look, moving the c over to the other side, right? And if I dropped out that bx, now I have this ax squared equals c. Okay, so there is going to be a really easy way to solve these. The really easy way to solve them is just take the square root of both sides. If I take the square root of x squared, I get x. Now what does that equal? The square root of 36, which is not just 6, it's both positive and negative 6. Okay, I can do the same thing with the next one. Take the square root of both sides. When it looks like this, in this form, okay, you could take the square root and say x equals both positive and negative 9. Okay, so try this next one. Take the square root of both, and x would equal both positive and negative 4. Okay, so don't let that fraction throw you. You're still going to take the square root of both sides. So x equals still 2 roots, positive and negative root. But 1 and 4, notice, they're perfect squares. The square root of 1 is 1. The square root of 4 is 2. And every single time you see this, how many answers do you have? 2. So for incomplete quadratics, you can simplify using the inverse of squaring, which is to take the square root. Okay? This allows us to isolate x, which is get the variable all by itself, which has always been the goal when we solve equations. But don't forget, you must include both the positive and the negative solution. Okay, so please understand that when we're talking about quadratic equations, right, there are going to be 2 solutions, a positive and a negative number. Same solution, one positive, one negative. And the reason being is if the degree is 2, highest degree is 2, which means it's quadratic, it means there will be 2 solutions, okay? And you'll have both a positive and a negative solution. It'll be the same number, but one's positive, one's negative. Now, some of you may see another type of way to solve these equations. If you notice, there is an additional strategy that you guys can figure out. If you have an example like x squared equals 36, where before I said, okay, x squared equals 36, we take the square root of both sides, and x equals plus and minus 6, like that in an instant. The other way you could do this is get your equation set equal to 0. So here, when instead of the 36 being on the other side of the equal sign, I would subtract 36 from both sides and make my equation x squared minus 36 equals 0. Okay, we set it equal to 0. Then notice x squared minus 36, it's the difference of two perfect squares, which is x minus 6, x plus 6. Remember, because the x squared is in front, you need the x's in front of the parentheses, and the 36, the square root, is 6 and negative 6, 1 plus 1 minus. And then just like we've been doing for I don't know how many weeks now, we set up our t, and we set each one of our factors set equal to 0, and then we solve. So notice, again, very important, these are your factors. These are your solutions. And notice our solutions are both positive and negative 6. And again, you could write it like this. You could write it the way I wrote it over here, x equals plus or minus 6. You could even just write out 6 comma negative 6. Those are your two answers. So I want you guys to pick whichever method you prefer. So for instance, if I do what we were doing before, and I say, okay, I know that x squared and 121, I'm missing my middle term, my x term. So I could take the square root of both sides, and x equals plus and minus 11. The square root of 121 is 11. Okay? In this second example, I'll just show it using factoring. So instead of taking the square root of both sides, and you don't have to do this, you could take the square root of both sides. If I take 49 and move it over to the other side, I would have x squared minus 49 equals 0. And then I'm going to factor. It's the difference of two squares, x plus 7, x minus 7. And when I set up my t, okay, I would show each factor set equal to 0, x equals negative 7. Here on this side, add x equals positive 7. So again, I have two solutions, plus and minus 7. Now look at the difference in work, A to B. To me, it's so much easier to use your square root method, where you're going to immediately take the square root of both sides. So x would equal positive and negative. That's the most important thing, that you don't forget there's always two solutions. And now I take the square root of both. The square root of 1 is 1. The square root of 9 is 3. So your answer is a third and negative 1/3. Again, you could switch the order. You could just write plus and minus 1/3. It doesn't matter. Okay, so all of these examples have been nice and easy. Why? Because you have perfect squares on the other side of the equation. So we can also use solving by square roots with non-perfect squares that are irrational numbers. So if you take a look at example number 4, let me just show you how you would do that. You now are still going to say, oh, okay, I could take the square root of both sides. But when you take the square root of x squared, you get x. That's going to equal plus and minus. Well, you now know it's just radical 10. You can't tell me 5. The square root of 10 is not 5. If I went into GeoGebra, okay, and I just showed the square root of 10, it's an irrational number, 3.16227. You're not going to write that. You're just going to use that radical and show that it is just the square root of 10. Not only the square root of 10, positive and negative square root of 10. Okay, so you could do that here too. 7's not a perfect square, but I can say x equals both plus and minus radical 7. And last, if I take the square root of both sides here, x equals both the positive and negative square root of 2. So that is perfect as answers. Once again, you could put them negative rad 10, positive rad 10 in a solution set. Here I could show both positive and negative rad 7 just like this. Okay, so however you prefer to show it, I could say rad 2 and negative rad 2. Okay, so that's it for today. I'm going to give you guys a little practice sheet, and let me know if you have any questions.